All right, we're switching gears. So if you didn't like what we were just doing, you can kind of leave it for a little bit. These things are all going to be related. We're going to be using all the same identities, but in a very different way. So I call the first half of this chapter sort of the simplifying chapter and algebraic manipulations. And then the second half of this chapter will be evaluating and solving. So the first thing we're going to do is learn how to evaluate with trigonometric identities using specifically the sum and difference identities. So we've already learned what the sum and difference identities are, but now we're going to look how to use them instead of for simplifying, but for evaluating. So for solving for angles that aren't our exact angles, right? Our 1, 2 root 3 and our 1, 1 root 2s, or our 30, 45, and 60, but that we can make into those. So the first thing I like to do, these two questions are in degrees, so we're going to write out what are those special angles that we know. So, I mean, I guess you could include 0, right? And then we'd have 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. Okay? And what you're going to do is you're going to add or subtract these special angles to get the angle that you're taking the sine or the cos or the tan of. So for example, if I want to find the sine of 15, I'm going to take two of these angles and either add them or subtract them to make 15. So I can do 45 minus 30, or I could do 60 minus 45. It doesn't matter. You'll get the same answer either way. Let's do 45 minus 30. It's usually the one that people see. So now what we've done is we've replaced the 15 degrees with special angles, and now we're going to use our sum and difference identities to now evaluate this. In other words, we can't take the sine of 15 exactly, right? Our calculator can do it to a decimal, but we can't find the value of sine of 15 exactly, but we can find the value of sine 45 and sine 30. So we're going to go over here and we're going to remind ourselves what our sum and difference identities are. So we're going to be looking at our sine sum and difference identities, and we're going to be looking at the sine difference identity. So the sine of angle u minus v would give us sine u cos v minus, so with sine the signs always match, and then cos u cos v, meaning first angle, second angle. So let's write this out. We would have the sine of the first angle times the cos of the second angle match the sine, and then the cos of the first angle times the sine of the second angle. And now that we no longer have it written as sine 45 minus 30, instead we have sine 45 and cos 45 and cos 30 and sine 30, we can evaluate. So we're going to draw our special triangles. You just need to fit them somewhere. And my 45 is my 1, 1, root 2 in quadrant 1, so everything's positive. And so the value of sine is opposite over hypotenuse, so 1 over root 2. And then always we rationalize that denominator, and we get root 2 over 2. Right, so this is our skills from chapter 6 coming back. So if they're foggy, maybe go back and review them. And then we're going to do the same thing with the cos of 30. So this was our 45, and let's draw our 30. I need to leave myself more space. I don't need all this space below, but here, we'll just draw it here. So if we're drawing a 30-degree angle, that's my 1, which is my smallest side across my smallest angle, 2, which is always my hypotenuse, and root 3, which is the one left over. So now we're doing the cos of 30, which would be root 3, or adjacent, over hypotenuse, which is 2. Or some people are already doing x over r, whatever you do. Okay, now we're going to move to cos of 45. So we're going to go back to this triangle. We've got 1 over root 2, so root 2 over 2 again. And then the sine of 30 is opposite over hypotenuse, which is 1 over 2. And then we simplify. So root 2 times root 3 is root 6 over 4, minus root 2 times 1 is just a root 2 over 2 times 2 is 4. So now we have a common denominator, and we get root 6 minus root 2 all over 4. And the nice thing about these is there's a very rhythmic pattern to this, in that the answer will always be some variation of this, because really our special triangles, we only have 1, 1 root 2 and 1, 2 root 3. So they always kind of end up the same. All right, let's give this one a go. And if you're ready for it, pause the video and give it a go yourself. Maybe you need a little bit of help getting going though. So this time, instead of adding to get positive 15, we're going to add or subtract to get negative 15. So what I would do instead is just 30 minus 45. So for this one, I'm going to do the cos of 30 degrees minus 45 degrees. So we can use these same triangles that we drew over here, but the first thing we're going to do is write this out. So again, you go to your formula sheet. This is a cos difference identity. So the cos difference identity goes cos first angle, cos second angle, plus. So this is the identities that switch signs. And then it goes sine first angle, sine second angle. So we're going to do cos first angle, cos second angle, plus sine first angle, sine second angle. And then we evaluate. And again, you'll get good at these. Like cos of 30, we've already done. Oh yeah, it was root 3 over 2. Cos of 45, we've already done. It's root 2 over 2. Plus sine of 30 is 1/2. And sine of 45 is root 2 over 2. Then we simplify. We get root 6 over 4. Oh, look at that again. Plus root 2 over 4. Ah, very similar. This time we get root 6 plus root 2 all over 4 versus root 6 minus root 2 all over 4. And I always like to mention, because it is good to be able to check your answers, if you plug into your calculator in degrees cos of negative 15, you should get the same as if you plugged this into your calculator. So it's a good way to check to make sure nothing went wrong. And now what we're going to do is we're going to do this all again, but in radians. So again, we have our special triangles, our special angles, so 0, 30, 45, 60, and 90, and we're going to write those in radians. So let's just write that here, and then we'll answer them below. I'm trying to figure out my spacing on this. So 0 degrees is 0 radians. Then we've got 30 degrees, which is pi by 6, and then we've got 45, which is pi by 4. 60, which is pi by 3, and then 90, which is pi by 2, dot, dot, dot. Then what you have to do is write these, because both of these questions are denominators of 12. What you're going to want to do is write all of these with denominators of 12, because then it's easier to see, should I add or subtract, and which two. So I'm going to go 0, 2 pi by 12, 3 pi by 12, 4 pi by 12, and 6 pi by 12. And then it's exactly the same. So I'll do this one with you. So we're looking for two of these that will add together to give me 5 pi by 12. So we've got the cos of what? Well, 2 pi by 12 plus 3 pi by 12 would give me 5 pi by 12. So 2 pi by 12 plus 3 pi by 12, which wasn't going to mean much to me. So I'm going to change them back to pi by 6 plus pi by 4. And then you just use your cos sum and difference identity. So for this one, it's going to go cos of the first angle, cos of the second angle, switch your sign, sine of the first angle, sine of the second angle. And then we evaluate. So it might help to draw those triangles again, even though we do have them above. So pi by 6 is my 30 degree. So it's my 1, 2, root 3. It's funny, and when I taught in the high school system, we would never work in degrees. And now that I'm working here and we do a lot in degrees, I swear it's harder, because your brain just wants to switch all the time instead of just accepting radians as the norm. Okay, so the cos of pi by 6 is going to be that root 3 over 2. Cos of pi by 4, so again, pi by 4 is going to be my 1, 1, root 2. So the cos of pi by 4 is that root 2 over 2 again. Sine of pi by 6 is 1/2. And sine of pi by 4 is root 2 over 2. Right? And if anybody's wondering, right, sine of pi by 4, opposite over hypotenuse, 1 over root 2, and then we rationalize the denominator. Okay, and then we are going to simplify. So root 2 times root 6, root 3 times root 2 is root 6, over 2 times 2 is 4, minus 1 times root 2 is root 2, over 2 times 2 is 4. Is this getting familiar yet? And then we end up with a common denominator of 4, and my numerator would be root 6 minus root 2. Awesome. All right, maybe pause the video and give this one a go, or if you're not feeling confident yet, you can keep watching. All right, so now we're trying to get negative pi by 12. So I'm going to look, oh man, it's getting kind of boring. Should we switch things up? I don't know what you guys are doing in the video, but you can do 2 pi by 12 minus 3 pi by 12, or let's go 3 pi by 12 minus 4 pi by 12, just to switch things up. We've been doing a lot with these two in here, the 30 and the 45. So let's do the sine of 3 pi by 12 minus 4 pi by 12, which is doing the sine of pi by 4 minus pi by 3, just to be different. So now the only thing we need to draw is that pi by 3 triangle. So pi by 3 is that larger angle, so it gets the root 3. So this is my 1, 2, root 3 triangle. All right, now let's write this out. So it's going to go sine of the first angle cos of the second angle, match the sign, cos of the first angle, sine of the second angle. And then we evaluate. So sine of pi by 4, we're looking back over here. It's that 1 over root 2, or root 2 over 2. Cos of pi by 3, we get to look over here, so it's a half. Minus cos of pi by 4 is root 2 over 2. And sine of pi by 3 is root 3 over 2. All right, what does that give me? Well, it gives me root 2 over 4 minus root 6 over 4, which would simplify to root 2 minus root 6 all over 4. Okay, I just paused the recording in case you guys were curious. So if there was anybody who'd worked on their own and kind of worked ahead and then came back, I just wanted to show you it's the same. So if we had the sine of pi by 6 minus pi by 4 instead of pi by 4 minus pi by 3, we still end up with root 2 minus root 6 all over 4. So it really does not matter which angles you pick as long as they add or subtract to give you that angle that they want. Good luck with these.